Hello everyone, my name is Chen, and I am a second-year master's student at Ningbo University. I'm excited to share with you the work enhancing home exercise experiences with video motion tracking for automatic display height adjustment that my colleagues Yuqi, Jintao Chen, Jiabao, Chong, Wang, Pinyan, Tang, and I accomplished together. My introduction consists of the following 4 parts: the background of our research, the method we applied, the user study we conducted, and the results from the data collected in the user study. Firstly, I'm going to briefly introduce the background of our research. The COVID-19 pandemic has driven a major increase in home fitness routines, as people have discovered the physical and psychological benefits of regular home workouts, especially during lockdowns. However, there is a problem with the traditional way of following exercises on a screen that's stuck at one height. It can block your view, cause you to over-twist your neck, promote poor posture, and ultimately provide a bad workout experience. Next, let's see about the method we have adopted. To address the problem mentioned earlier, we developed a technology for automatic height adjustment in real time. It uses skeletal tracking data of the exercise demonstrator. Specifically, we use a graph neural network to predict the demonstrator's shoulder height based on body key points, such as shoulder, elbows, and knees. Additionally, when fitness aids such as a yoga mat are in view, we use the perspective endpoint algorithm to estimate the camera's position. With these data points, we calculate the physical vertical height of the shoulder throughout the routines. We then created a height control curve based on these estimates, which works with an adjustable desk controller. We used a wireless serial port to connect the computer to the controller, allowing the screen height to be synchronized with the demonstrator's movements, giving you optimal view angles and ergonomics. To show how well our algorithm works, we tested with different exercises, such as aerobics, strength training, and yoga or Pilates, focusing on its performance with varying lifting speeds and duty circles. Next, let me walk you through the user study we conducted. To evaluate our technology, we carried out a user study involving 30 participants, ranging in age from 19 to 27 years old. The participant pool consists of 8 females and 22 males. We intended to test our technology from both objective and subjective perspectives. Therefore, our research revolved around 3 key questions. First, we looked at how the automatic height adjustment feature influences the angle of head flexion in participants to understand the postural effects. Second, we utilized subjective measures to evaluate the impact of our technology on mental exertion, physical demand, time pressure, frustration, and effort level, as well as on the overall exercise performance. Lastly, because of the importance of feeling supported and engaged during exercise routines, we also tested the technology influence on these 2 aspects. During the user study, each participant tried out 3 different conditions in randomized order: a fixed height desk, a manually height adjustable desk, and a desk with our automatic height adjustment technology. This within subjects design allowed us to compare their experiences across each setup when performing the same exercise. To measure user experience, we utilize both objective and subjective approaches. Firstly, as shown in the pictures, we develop a head angle measurement method using two well-test sensors to quantify head flexion angle and posture during exercise. One sensor was placed on the back of the head to measure the angle between the head plane and the vertical plane. The second sensor was placed on the upper back to measure the trunk angle relative to the vertical plane. Also, the participants were instructed to complete a weighted NASA-TLX questionnaire after each condition to assess perceived workload. The adapted NASA-TLX survey was developed by extending the original version and adding 2 dimensions for evaluating the degree of participation and feeling supported during exercise. This allowed us to gauge how engaged they felt and how well they thought the desk supported their workout. The last part is about the results we obtained. The head flexion data results show that our technology significantly decreased upward head flexion angle compared to the alternative conditions, demonstrating that it promotes better posture and ergonomics. In terms of subjective feedbacks, the participants reported reduced mental demand, less frustration and effort, as well as enhanced performance and feelings of support when using the automated system. We also explored the influences of other factors such as gender, experience with height adjustable desks, exercise habits, and height on the TLX evaluations. We found that male participants experienced higher physical demand with fixed height desks, and those with experience using height adjustable desks felt more time pressure under the same condition. Additionally, people with regular exercise habits experienced reduced temporal demand under the fixed height condition and lower mental demand under the automatic height adjustment condition. Furthermore, participants with regular exercise habits tended to experience a higher level of participation under the fixed height condition. We also evaluated the influence of participants' height on the TLX scores. We found that participants taller than 161 centimeters showed great confidence in their performance with manually adjustable desks. In summary, according to our user study, both objective and subjective evaluations demonstrate that our automatic adjustment technology improves the user experience when following a workout video. Nevertheless, such experience varies with factors such as gender, past experience with height adjustable technologies, exercise habits, and height of the users. Further studies are needed to look into these correlations for more in-depth understanding. That's all. Thank you for listening. If you have any questions, feel free to contact us via the emails.